Linearization and differentials. Let's recall how to linearize a complicated function. We take the y equal to f of x, find the point evaluated at x equal to a and the y value that you plug in for the x in the function, take the derivative of the function so that we can find the slope at x equal to a. Then use the slope point form to find the linearized version of f of x, which is the approximation of the function, and it's approximated by a linear function. Find the linearization of f of x equal to the cosine of x at the point when x is equal to pi over 2. Okay, first thing we do is we evaluate the point, so find the point. To get the point, we let x be equal to pi over 2, and of course f of pi over 2 is equal to the cosine of pi over 2, and what is the cosine of pi over 2? It's 0. So the point that we have is where we have our localized approximation is at pi over 2, 0. Okay, the next thing we do is take the derivative of f. So the derivative of cosine x is negative sine x, and then to get the slope we just substitute y prime at pi over 2, which means it's the negative of the sine of pi over 2. That's equal to negative 1. And then after that, we use the slope point form, which is y minus y1 equals to the slope times x minus x1. So our y1 is 0, our x1 is pi over 2. So y minus 0 is equal to negative 1 times x minus pi over 2. So that's equal to negative x plus pi over 2. This is the linearized approximation of the cosine function at the point pi over 2, 0. So what we can say now is that at x equal to pi over 2, cosine of x is approximately equal to negative x plus pi over 2. And here is our equation y is equal to negative x plus pi over 2, and you see that it's just a diagonal line that's sloping down, and it's a linear function, and of course that's where it's passing through the x-axis at pi over 2, 0. And in a localized area, the line is approximately equal to cosine of x. Let me go ahead and work a few more problems from the back of the book. Out of these, we're asked to find the linearization L of x of the function at specified a. Okay, let's do number 1. F of x is equal to x cubed minus 2x plus 3. And we are to evaluate it or look at the linearization at a equal to 2. That means at x equal to 2. So first, let's get the point. F of 2 would be 2 cubed minus 2 times 2 plus 3, and that would be equal to 8 minus 4 plus 3, we get 7. So the point, therefore, that we need for the tangent line is at 2, 7. Then the next thing we do is differentiate. So y prime is equal to 3x squared minus 2. And then to get the slope, we evaluate it at x equal to 2. So the slope will be 3 times 2 squared minus 2. And that's 12 minus 2. We get 10. That's your slope. Now we're ready to write the linearized version by taking y minus y1 equals m times x minus x1. So y minus 7 is equal to 10 times x minus 2. And we simplify that by letting y equal to 10x minus 20 plus 7, that's equal to 10x minus 13. Therefore, x cubed minus 2x plus 3 is approximated by the linear function 10x minus 13 at the local point where x is equal to 2. Okay, how about we work on number 2? Number 2, we have y is equal to the square root of x squared plus 9, and it's evaluated at x equal to negative 4. Another way of writing y is in terms of its power, x squared plus 9 raised to a half. And first we look at the point. That's when x is equal to negative 4, then y is equal to the square root of negative 4 squared would be 16 plus 9 would be 25. Take the square root of 25, and that's how we get 5. So the point would be, the point therefore would be negative 4 at negative 4, 5. Okay, the next thing we need to get is the first derivative. The first derivative would be 1/2 times x squared plus 9 raised to a negative half, because 1/2 minus 1 is minus 1/2. By chain rule, we need to take the derivative of the inside, which is 2x. That cancels out that part. So what we've got is x all over, because of the negative power, then it brings it down. Okay, so once we've taken the first derivative, now we can get the slope, which is at negative 4 over the square root of, we know what this is, that's the square root of 25, so it's equal to negative 4 over 5. So now we'll take the slope point form. So y minus 5 would be equal to the slope, negative 4 over 5, multiplied by the quantity x minus a negative 4. Okay, so that's equal to y minus 5 equal to the negative 4 x over 5. All right, and then there's what we've got is a negative of a negative, that's positive. Then you multiply by a negative, so it's negative 16 over 5. And the rest would just be a matter of combining. So y would be equal to negative 4 over 5x minus 16 over 5 plus 25 over 5, so that we can get the common denominator. And that leaves us with the linearization. When we add these two together, what we'll get would be a positive 9 over 5. So The square root of x squared plus 9 is approximated by the line negative 4 over 5x plus 9 over 5 at the point where x is equal to negative 4. We've got our linearized version right here to approximate the square root of x squared plus 9.